Good morning. Bhagirat. Hello, Bhagirat.
Yes, sir.
What we are doing in the last class?
Sir, last question mo option islo sir. Gabi asil mo.
Deepak, you were present? Deepak, were you present in the last class? That means on Thursday. Others, can you hear me? You can hear me, but I cannot hear you. Okay, last class, we did actually? I forgot. Can you tell me? Pardon? Problems. We did some problems, right? Okay. Okay, anyway, today we'll be doing principal stresses and strain, the different forces, and to find the stresses and strain, the shortcut method, rather we can say. Is it visible? Is it visible to you?
Yes, sir.
Okay, write down. Structural member may be subjected to not two, maybe two, may be subjected to different type of stresses. Simultaneously. It is therefore necessary it is therefore necessary to find a region where the effect of the stresses will be critical from the from the design point of view. When such stresses act at a point, in a stressed material, there always exists three exists three planes carrying entirely three orthogonal planes. The orthogonal planes carrying entirely normal stresses, carrying entirely normal stresses. That means with no shared stresses at all. At all. Such planes are called such planes are called principal planes. Principal planes and the normal stresses and the normal stresses acting on them are called principal stresses. Principal stresses. One of these principal stresses is the one of these principal stresses is the greatest normal stress and one of them is the and one of them is the least normal stress.
आपका आईडी प्रूफ हो गया, आईडी प्रूफ का बाद आएगा आपका एज प्रूफ। इसमें सिग्नेचर तो बोलेंगे ना, मैंने बोला पासपोर्ट को सिग्नेचर, फिर आईडी प्रूफ, फिर आएगा आपका एज प्रूफ। एज
It is
प्रूफ
therefore necessary to find out.
लास्ट टाइम एडमिट कार्ड ये सब।
It is therefore
हाँ, लेकिन उसमें भी आपका जेरॉक्स जितना भी डॉक्यूमेंट है
necessary to find out
आपका सेल्फ एड्रेस, ठीक है। एज ग्रुप का बाहर आएगा आपका लास्ट टाइम का सर्टिफिकेट और मार्कशीट।
to find out
हाँ, लास्ट टाइम
this
सर्टिफिकेट
greatest normal stress is
हाँ, डिप्लोमा फिर लास्ट टाइम का
sorry there is greatest
ठीक है।
it is
और
greatest
finally आपका एक एनेक्सर 1
greatest
मैंने एनेक्सर 1 को किया हो, ठीक है। वो एनेक्सर 1 को सिर्फ आपका
stress
विद सिग्नेचर आपका और कोई भी एक गार्जियन बोले तो आपका मम्मी पापा या फिर कोई भी रिलेटिव हो जो गार्जियन है, ठीक है।
that is the maximum principal stress
हाँ, ये अभी तुरंत आज करो, ठीक है।
maximum principal stress which
मतलब 15 में
maximum principal stress
अच्छा कहाँ पे एक बार
which shall not exceed
हाँ वो देखो अभी आप लोग आधा
the permissible value
फोन में तो सॉल्व करने के लिए प्रॉब्लम है ना। हाँ, अभी क्लास करो कोई प्रॉब्लम नहीं, अगर कुछ ज़्यादा इशू होता है तो मैं
permissible value for the safety of the design.
नहीं हुआ एक बार आंसर आप बाकी ये आप लोग ठीक है।
So this is all about principal stress and principal plan. Now slowly we'll move to the case study in which the stresses will be applied in different direction, maybe oblique, maybe orthogonal. In that kind of situation, what will be the equation for principal stress, strain, shear stress? Those things will now derive, and these things will be necessary for finding out the stresses for problems. No, so if you look at the problem, the geometry of the problem, if you take the free body diagram and then resolve all the forces and then do the calculation by using this type of formula. So it is this derivation is not necessary for your exam point of view. So you don't have to derive in the exam, but the concept is necessary to solve the numerical. So next we'll be deriving the equations for normal and tangential stresses. Is it done? Can I scroll down? Can I scroll down?
Yes, sir.
Yes, sir.
Okay. So these were some basic definitions of principal stress, principal plans, normal stress. So next, the main case, the scenario. Normal stress and this and tangential or shearing stress, shear stress, tangential or shear stress, same thing. So if you look at the figure, these are the direction of force. We can call it ABCD. This is a square block, huh? Though it is not square in my drawing, but it is a square block. Now take a slender piece. Take a slender piece like this. Okay, suppose this is making an angle theta. Fine. So here it will be the direction of stress Pm, and this will be your tangential stress PT. P tangential PT, and Pn means P normal. Okay, so this is the geometry of the figure. So now we will find out what will be PT and what will be PM. See, again I am telling, if you look at this type of figure in numerical, then immediately you have to relate the equations which is given for normal stress and tangential. So that is we are going to derive now. So the derivation is not that necessary, but it is necessary from solving point of view. If you want to solve some numerical, by look at the figure, you should relate these things with this theory. That is why I am going to solve this theory. I am going to derive the basic equations. Fine. So the case one is member subjected to, first case maybe, these are all related to practical issues from design point of view. Okay, the member subjected to an axial load. To an axial load. So this is a figure, suppose, let me call it figure 1. So when you start the sentence with the word figure, then you have to write the complete letter, complete word, F-I-G-U-R-E. But if you are writing in between a sentence, then you have to write only small f-I-G dot. That thing I have been repeating every day, so you should remember it. Figure 1 shows a rectangular bar A, B, C, D of uniform sectional area. Let the member be subjected to an area full stop. Let the member be subjected to an axial tensile load, axial tensile load W, producing a tensile stress producing a tensile stress. So sometimes stress is given by sigma and sometimes it is given by P, small p. So that you don't have to confuse with that. Okay. Sometimes it is denoted by this, it is the notation what you are following. But if you write beforehand the tensile stress you are recognizing by P or sigma, that is good enough. Okay, but if you directly write small p, if you directly write P, or if you directly write sigma, so it will carry no meaning. So you have to be careful in that. Since I have written tensile stress now, so I can put P. Although we have been using sigma for long, but P can also be used. This is a notation, simply notation. So you have to write. So W by A on sections normal to the axis of loading. On such a section, normal to the axis of loading, only normal stresses are induced and no tangential stresses are induced. Considering an oblique plane BE as shown in the figure, as shown in, now it is peak dot one. Okay, so you have to see the difference. As shown in fig 1 at an angle theta, at an angle theta, to the cross section. One of the plane BE normal on the plane BE, normal tangential stress are induced. So tangential stress or shear stress is along the surface of the plane. Okay, and but the stress which is perpendicular to the plane, that is your normal stress. Okay, do you know what is area vector? Can you tell me what is area vector? What is its direction? Can anyone tell me? Suppose you have a rectangular block ABCD. If I am asking you to assign the direction of the area vector, to in which direction you will provide it? Bhagirat, do you have any idea?
Yes, sir.
So now you tell me, suppose you have a plane ABCD, so which way your area vector will be assigned? Is it along the surface, normal to the surface, inclined to the surface, below the surface? Which way? Which direction? Others?
Sir, incline, sir.
Incline. Your plane is falling on the floor, suppose. It is kept on the floor. Then, see, in this scenario, I am not able to draw.
So it will depend upon the
Anyway, it will depend upon the plan.
of
It is depend upon the plan actually, how you have put it, how you have kept it. But the thing is that it is always normal to the plan of that block or of that sheet of that plan of that paper. Okay, suppose the page of your book, okay, your book page, so its direction, it is having an area, so its area vector will be moving upward or downward. Okay, it will always be normal to the plane. Area vector is always normal to the plane. It's not inclined. It will be inclined with the x-axis if you have put your plane also inclined to the x-axis. Okay, but normally if we put the plane in the floor, that means horizontally, then the area vector will be directing towards upward direction or maybe towards direction, the downward direction, that is in the positive or negative y-axis. You remember that. So in this case, BE plane, you see it is inclined. So in that case, inclined to what actually? It is not a complete sentence if you say something inclined. Inclined to what? That reference should be given. It is inclined to x-axis. Okay, with an angle 90 plus theta. If you look at the diagram, you will see that it is inclined to the x-axis. The plane BE is inclined to the x-axis at an angle of 90 plus theta. Fine. So in that case, the normal, that means area vector, direction of the area vector will also be inclined to the x-axis. But with respect to some other plane, it will be always perpendicular. Okay, if you have changed your frame of reference, then your direction you cannot say this is inclined. Let me take that frame of reference as my original frame of reference. So in that case, you cannot say inclined. So whenever you say what is the distance, if you don't say the from where, then your sentence is incomplete. Okay, sometimes normally in colloquial language we ask that what is the distance to your home, but you have to mention from where. Is it from Delhi or is it from Guwahati? So that you have to mention. Fine. Similarly, whenever we say that it is inclined, with respect to what? But it is pre-assumed that whenever we say inclined, it is our x-axis or y-axis. We pre-assume, but it may not be the case. Okay, so that you have to consider when you are doing some problem. Okay, now you see in the plan B, since it is inclined to the x-axis, so the normal forces which were acting on the plane ABCD, which were in a align with the x-axis, it will be now in inclined motion. Okay, your force will be inclined. In that case, both shear stress and normal stress will come into play. But in the other case, first case, when we didn't tilted it, there we got only normal stress. There was no tangential stress. Tangential stress, you can remember sideways stress. Am I clear? Are you clear or not? Let me know. Bhagirat, who can hear me? Who?
Yes, sir.
What? Yes, sir. Is it clear? Russell, can you hear me? Anybody who can hear me, please answer. Is it clear or not? Why plan B is having both tangential and normal stress, but the plan AB is not having the tangential stress, it is the only normal stress. So that point you should be clear in your mind. Okay, let's move. are induced. Okay, the sectional area of the member, you write down the sectional area of the member along the plane BE Just tell me how much it will be. That will be your A sec theta. Let me write here. A sec theta. You understand? Equal to normal stress on the plane BE equal to Pn normal. Total force normal to the plane BE total force normal to the plane BE sectional area along the plane BE okay. Now or Pn is equal total force normal to the plane BE will be area into stress, so P into A sec cos theta by area factor, that is A sec theta. Or do the trigonometric operation, 1 by sec theta is cos theta and A will get cancelled out. Ultimately you are having P cos square theta. So P cos square theta, Pn is equal to, okay. So this is a very easy formula. So if you find some numerical where stresses are given in this type of pattern, then you can directly apply this formula that your Pn will be P cos square theta, like we did in Morse circle. Now that we will go in details again and try to solve some problems also Morse circle. Okay, so in Morse circle what we have got, that we have to construct one circle at the center of the circle, at the periphery of the circle if we get different stresses, no. So directly by drawing the diagram we can have the representations and directly we can find out the results. So it can be find out even in 30 seconds. But if you are going to the analytical process, not there you have to find deduce everything, you have to apply all the concepts. Fine. So this is the pictorial views are always very easy to understand. That is why if you look at some numerical in exam or anywhere uh, of this pattern, particularly suppose there is an inclined plane, so directly you can find out the Pn by using this formula. So this is necessary from engineering point of view. This is necessary. If you are working in some design companies also, there also this formula will come. Some more formulas will be there, but this is the basic that you have to find out. Similarly, we can easily find out the tangential stress on the plane B. This we can say shortcut formula. Tangential stresses on the plane BE. Can anybody tell me what is the tangential force on the plane BE? Others, can you tell me what is the shear force on the plane AB? Can you hear me? Can you hear me? If you can hear me, then answer. Bhagirat,
Sir.
what is the shear force on the plane AB? Tangential force along the plane BE.
Don't know.
You don't know? That is zero.
Don't know. Sir.
That is zero. Tangential force on the plane AB is zero. Why? Because all the forces, you can look at the diagram, that it is acting normally. So if all the forces are acting in the normal direction, then how can it be possible to have your shear stress along that plane? See, I have been telling repeatedly, there should be shear stress only when there is some inclination is there. Okay, and the force, of course, you have to apply normally. But if you're using your force at an incline, so that means there will be definitely put two stresses, tangential stresses and shear stresses. Okay, so remember always that if your force is acting perpendicular to the plane, then there cannot be the chance of having shear stress. So in the plane AB, the shear stress is nil, or you can say zero. So tangential force along the plane BE. Are you clear or not? Sectional area along the plane BE. So it will be PA sine theta PA sine theta by x sec theta. So like the previous case, it will go and 1 by sec theta cos theta. So P sine theta cos theta. This P is small letter, huh? Because P is pressure, and pressure is always denoted by small letter. In thermal also you have find that P is denoted by small p. If you write capital P, that will mean load or force, but small p always indicate pressure. So stress is nothing but pressure, force per unit area. So this is small p. Therefore, Pt is equal to, so little trigonometric improvisation we will do. So let me just bring P 2, then you write sine theta into cos theta. Since these two we have written extra, so let me multiply it by 2. So 2 sine theta cos theta is sine 2 theta and P by 2. So little we have done some improvise here, trigonometric ratio that you are already know about trigonometric ratio. So P sine 2 sine theta cos theta is sine 2 theta. Now we have to find out the resultant. So resultant, you remember what is resultant force, what is resultant stress. So P resultant. So that we are very much clear about that. It will be Pn square plus Pt square. Now you put and do the calculation. All of you please do it. Put the expression for P, put the expression for T and PT, then you calculate the overall equation for resultant pressure. And tell me how much you got. How much you get? You tell me how much you get? So you write down P square cos to the power 4 theta, then P square sin square theta into cos square theta. Take common P square cos square theta, take common. So it will be cos square theta, it will be sin square theta. Cos square plus theta plus sin square theta, how much? 0. Cos square theta plus sin square theta is equal to 0. Am I right? Am I right or wrong? Sin square theta plus cos square theta is equal to 0 or pi? How much? Others? Okay, come on, anybody tell me, no?
1.
Is it 1?
Mm.
Okay. So I take your decision. So P square cos square theta under square root. So that will come out as P cos theta. Okay. So finally P resultant, we have got P cos theta. Okay. So this is the case for a member when it is subjected to both axial loading, and if you incline some plan on that, or if you slender some plan, and then you will find out the PT, that is tangential stress, PN normal stress, and then finally you get the resultant stress. Okay. Okay. So if theta is equal to 0 degree, how much should be PR? How much will be PT? How much will be PN? So PR will be cos 0 is 0 or 1. So that will be cos 0 is equal to 1. Then PT, what is the expression for PT? So if sin 0 0, so PT there will not be anything. And what will be the PN? What will be PN? It will be P. So now look at, if you are not tilting your plan, then the force that will be remaining only normal force, and there will not be any component for shear force. Okay, that means there will not be any shear stress, only normal stress will be available, and that will be equal to the resultant stress. Okay, if theta is equal to 0, that means you are not tilting your plan. or your plan is vertical to the x-axis and you are applying load along the x-axis. Okay, so the figure ABCD. Okay, but if you take the figure DEBC, then both will come into play depending on the theta. So let me now take Bhagirath, can you take the attendance and send it to me? If theta is equal to pi by 2, so PR will be 0. Cos 90 is equal to 0. PT will be, now there should come value. PT will be, so pi by 2 into 2, so pi. It will be also 0. Sin 1t is equal to minus 1, no? 2 pi by 2. So sin, it will be 0, sin 0, and Pn will also be 0. Bhagirath, you take the attendance. Okay.